Today is Tuesday, April 23rd, 2024. We are here today. This is the makeup class for the week of March 23rd. I believe it was through actually it's 25th through the 28th, I believe. Yep, 25th through the 29th. So this is the second makeup class that we are actually doing now for that particular week. All right. So just to do a recap, so we've been in the hardware section. And then the hardware section, we've covered everything from network media, bounded media and unbounded media, copper cables, coaxial cables, twisted pair cables, which are copper cables as well, fiber optic cables. We've talked about the connectors to most cables as well, and the different ports that are on networking devices, computers, things of that nature. We talked about SATA cables, SATA connectors. We talked about HDMI. We talked about the RCA jacks, the SPDIF ports. We talked about a number of different things, peripheral devices, and their cables. We talked about the DE15, the DB9s, the 6-pin mini DIN or mini DIN 6, in most cases, the old school mouse and mouse and keyboard ports. We've also talked about the different types of USB ports, the USB-A, USB-B, micro USB, mini USB, USB 2.0, USB 2.3, 3.0, and 3.1. We've also talked about, as I stated before, SATA and PATA and the difference between the two. PATA is more associated with older school technology, such as an IDE, I think it's integrated designs, hard drives, and now we use the more current SATA drives, the serial advanced technology attachment, and there's L-shape connectors with the L-shaped cable that we usually connect to the motherboard. All right. We talked about cases and the form factor. Your power supply, your motherboard, and your case have to have the same form factor. If it's an ATX motherboard, you want to have an ATX case, and you want to have a nice, sufficient power supply to connect with that as well. All right. We've also talked about troubleshooting certain motherboard issues, making sure that the power connector holds a voltage, and that connector, the eighth pin, making sure that that eighth pin is working and firing properly, because that is your power pin, okay, on that connector. All right. We've talked about the capacitors on any particular motherboard, or what we call a PCB board or system board, because we want to make sure that those connectors don't go bad, because if they do go bad and there's corrosion or there's a ooze coming out of them, what's going to happen is the motherboard is going to go bad. Okay. So then we got into memory. We talked about dynamic memory, dynamic RAM. Let me start off this way. We talked about RAM and ROM and the differences between RAM and ROM. That RAM is read-only memory, meaning that it's volatile. If anything happens to your system and it cuts off, what's going to happen is that your system will stop working. Stop working. It will stop storing information, and you may have lost data, or data, if it's saved, if there's a certain point in which that information will save. Then there's ROM, read-only memory. These are flash chips that can be programmed with certain information, and when the computer turns off, the information or the data will not disappear. Okay.
I'm sorry, Professor, because you said RAM was read-only
No,
memory? You said ROM was read-only memory?
yes,
So,
ROM is read-only memory.
and RAM was what?
Random access memory.
Okay, that's what I was looking for. Thank you.
Yeah. So that just means that it's volatile. If your system cuts off, everything leaves the RAM chips. But ROM chips, sort of like your firmware chip, which is a type of ROM, read-only memory, they're programmed with information, and that information will not be deleted unless certain things happen. Okay. We've also talked about the clock cycles, and how now that we have double data rate, or DDR, There's 2 times of the data that's going to move in one clock cycle. And as our generations of RAM increase, that begins to double, but it takes less power. We also talked about the DIMM chip and it being a DIMM dual inline memory module because there's 2 sets of pins on both sides. A typical memory module is going to have 8 pins, or DIMM chip, no matter if it's a SO-DIMM, UNIDIMM, or a regular DIMM module. Um, with that DIMM module, we also said that the speed of the RAM chip must match or be higher than the speed of the processor. Okay, so if the processor is at 2.8 megahertz or 2800 megahertz, then the RAM chip must be at 2800 megahertz or greater, 3200. Okay. We also talked about the PC denotation as well as the DDR. We talked about frequency versus bandwidth. You want to know the difference between those. And we also talked about multi-channel memory. So if you have a quad core, you have 8 memory slots. If you have dual core, you have 4 memory slots. If you have triple core, if you have, not triple core, triple channel. I'm talking about cores. It's triple channel, dual channel, and it's quad channel. So if you have triple channel, you have 6 RAM slots, and then they'll be color coded as to which RAM will work together. Okay. We also talked about certain characteristics of RAM. We talked about there being a parity RAM where there are 9 chips on the memory module. And when the bits or a particular app or something, or if all the bits don't go, then there's a 9th bit that is added that will give the program all the bits that it needs to run. Then there's error correcting code. Now, parity RAM can't fix errors. It can recognize it, but error correcting code can fix those errors. And that's a type of RAM as well. We also said that certain RAM issues will cause certain things to happen. If your RAM is not working, your screens may not come on. If your RAM is working, the computer may intermittently stop working. It may turn on and turn off, turn on and turn off. We also said that your RAM has to match. And when you're placing RAM in the slot, you should hear a click as well. If there's also an issue with the RAM, you'll either get an audible beep code, or you'll get an error message on the screen, or you will get a post message if you have a post card. Okay. We stated that the RAM is integral because the operating system and the associated apps have to sit on that RAM chip as well. Okay. And then we led into the BIOS and the UEFI. Oh, I forgot one thing. We also talked about latency, the latency of when you request a program and the time it takes for the program to get on the RAM chips and the actual application to start. So that gap of time for when you request it till it shows up on the RAM is called CAS latency, CAS latency. Okay. That's the gap of time it takes a program to from request to I want to say maturation until it reaches the RAM. When it reaches the RAM, that gap between that time is called your CAS latency. Okay. Now, we also brought up facts about the BIOS. We talked about BIOS and UEFI. How BIOS is a legacy firmware chip, and the UEFI is the current modern firmware chip that we use today. We said that the differences between the two is the fact that if you have an issue with your computer, that you can access the internet by booting into safe mode. What safe mode does is safe mode allows you to access the computer, but you're only going to use the resources that are necessary for the computer to run. Okay. It won't be all the bells and whistles, but it will give you the opportunity to go into the UEFI. And when you get in there, you can go online and you can download software and drivers to help fix the computer. Okay. The BIOS has what is called the MBR, the master boot record. Please make note of this. The master boot record. So after the post, when everything is checked, when you first turn your computer on, then a signal is sent to the hard drive to look for the booting file, or the what we call the bootloader. So you have to find the master boot record. When in legacy systems, once you find the master boot record, then you find the kernel to the operating system, as well as you find the apps that are associated with starting up or loading the operating system onto the RAM. Okay. In UEFI, it's the same process, but a little different. With the UEFI, you're looking for what is called the GPT. And the GPT, I'm going to click here real quick and get rid of this. Your GPT, let's see if it's here. In this note section, it is not there. Let's back up a bit. And go to flashing the BIOS. Okay. So your GPT stands for your globally unique identifier partition table. GPT. BIOS. UEFI. So real quick, just to give you a little bit. So what is the GPT? So your GPT, it says when you deploy Windows to a UEFI-based device, you must format the hard drive to include the Windows partition by using a GUID partition table. All right. And this is the filing system, the file system. It says additional drives may use either GPT or the master boot record file format. So let's go here 1 second. I'm gonna go online and I'm gonna go to Surety Cyber, Sure Cyber, which is my page. And that's not it. This is it right here. This is the exact video where I explain this process, because before I started talking about virtualization, I talked about the kernel of the operating system and how the kernel of the operating system relates to the formatting of the drive, because the filing system is going to determine the formatting, the partitioning, and how information is going to be saved onto that particular drive. Give me 1 minute. Let me let Rosa in. She didn't drop off. Okay, Rosen. I'm sorry. So right here, this is my actual YouTube page that focuses on cyber. Okay. You'll probably see going forward, you'll see a lot of things here, especially for when I teach at the college on the credit side. The side that we're teaching on right now is the continuing education side. Okay. So you'll see those things. But this video right here, CompTIA A+ certification, training visualization. When I start this video, I start talking about this process that we're describing here, how the BIOS and the UEFI actually looks for the GPT or the MBR, depending upon what type of firmware that you're using and the type of computer. Let's just go over some of the facts that are associated with the UEFI. So the UEFI was designed to replace the BIOS, which stands for Basic Input Output System. The UEFI stands for Unified Extensible Firmware Interface. It says UEFI is firmware. This is the chip that sits on the motherboard. It's referred to as an EEPROM chip, electronically erasable programmable memory. Okay. Here it says the UEFI program controls the startup process. It also loads the operating system into memory. The UEFI design improves the software interoperability and the address limitations of the BIOS. Okay. When it says the address limitations, they're talking about how it uses binary to find information. Okay. The UEFI use what is called bit mapping. So if I was to explain bit mapping on a hard drive is similar to GPS in our world. So the UEFI can look at the entire drive and know where things are located because it has a table that has recorded where things are located. And we refer to that as a bitmap. Okay. Um, so the UEFI also provides better security against blocks or bootkits or root attacks, okay, or startup attacks, configuration registry attacks. So, and to explain that, we want to go here. Give me 1 second so that I can further explain the security that's kind of associated with UEFI. All right, so I want to go here and go into BIOS security. And let's make this just a tad larger. Here are some ways that you can secure the BIOS. You can have a BIOS password and a user password. And that means as soon as you turn on your computer, you would have to enter a password. It can be dangerous sometimes. In order to stop that from happening and to reset the password, you would have to go on the computer and take out the CMOS battery. If you take out the CMOS battery, that will reset the username and password, okay, or the BIOS password, excuse me. You also have what is called full disk encryption. That means you can encrypt your hard drive. You can encrypt the hard drive. See, everything is encrypted, not just individual files. There's a tool that's called BitLocker. BitLocker is used so they can encrypt your hard drive. This is good when you work for organizations where your data has to remain secure, like governmental organizations. All right. In order for BitLocker to work, you have to use what is called TPM, or Trusted Platform Module. So these are things that when you go in the BIOS, you would actually turn these things on, okay, or enable them. So because the real technical term is enable and disable, okay. So if you access the BIOS, you would use either your delete key, your F1, F2, F10, F11, F12, your escape key, depending on the type of motherboard that you have. And there's more. So TPM, Trusted Platform Module, you must turn these on. Once you turn this on, this creates cryptographic or encryption, okay? Cryptographic functions. So it adds advanced cryptographic functions, meaning now encryption is now on your motherboard. So if programs try to make changes, they'll have to access the system and it'll be verified to see if they have the same keys that will allow them to make changes. If your computer gets stolen, there's a tool called LoJack. LoJack is for laptops. And what happens is if you have LoJack enabled on the motherboard, what happens is once your computer gets closed, shut, locked, and you leave it in a car and someone takes it, you can find it by going through LoJack, just like Cadillac cars that have LoJack as well. All right. Secure boot. This is what we were talking about. So once you enable TPM on your computer, then you can use Secure Boot. What Secure Boot does, it creates what we call as digital signatures. Okay, this is a UEFI specification. This is not in BIOS. Okay, this is in the UEFI where you have Secure Boot, just meaning that your firmware chip is protected because they're a trusted platform module. And when you turn on Secure Boot, now you have encryption keys that are created. So some programs will want to change your firewall, will want to change your configurations, and that can't happen unless they have the digital signature. Okay. So software won't run without proper signatures. Support in many different operating systems takes place, such as in Windows and Linux. Okay. So we talked about that yesterday. We introduced that. Please, I implore you to go through this, your CompTIA book, and the test out quizzes and the test out information. If it's better to view this and go through your CompTIA book, do that. But we want to drive some of these things home so that you'll understand these concepts. Okay. A little more about the BIOS is that if you wanted to upgrade the BIOS, you would have to do what is called flashing the BIOS. In most cases, you would have to download the BIOS onto a flash drive. Once you go to the website, you want to ensure that you've identified the right motherboard and the motherboard manufacturer, and then you're going to download any tool they have available or the actual firmware software. Once you download that, then you're going to log into the BIOS. After logging into the BIOS, then you're going to go where you can upgrade or update the BIOS and do it there. One thing I want to say to you is once you start upgrading the BIOS, don't jolt the computer, don't shake the computer, don't do it through a power storm, don't do it through a outage, because if you mess up the BIOS, your motherboard is toast. Okay. All right. If everybody got that, leave one in the chat. You said, yeah, it'll be a brick. You're right. So, also, you also want to make sure that you're using the right version. Okay. Another thing that can help you find system information about your computer, okay, is you would right click and you will go to settings. Once you go to settings, you want to go to system. Once you go to system, you scroll down to about, and about will give you more information. Since I would be posting this on social media, I'm not going to go into it too much. It's enough that I got my information right there. All right. Then the other thing you can use is you will go to your search option and type in MS Info 32. MS Info 32. All right. So, or you can hit Control R. I'm sorry. If you hit the function key on a Windows system and you hit R, then you'll get this run dialog box. And when you get this run dialog box, then you can type in things like MS Info 32, hit OK, and then your information populates as such. Okay. All right. I'm sorry, that was the wrong one. This is it right here. This is the system information. All right, I'm going to move that out of the way. I'll be cutting and deleting that out because then if I put that online, what's going to happen is people will be able to access my information. This is why I try to be very careful with what I put out there. All right. So these are just some things that you want to think about before upgrading. Read the documentation. Some BIOS updates are bland. Others are full of new features. Check the OS prerequisites. Check your hardware prerequisites as well if you're updating. And we'll get into CPUs in a minute, but not right now. Okay. So other things to consider about the UEFI. The UEFI supports hard drives larger than 2.2 terabytes. It also supports 64-bit firmware device drivers, which are really associated with 64-bit operating systems. Then you have the UEFI is compatible with both BIOS and UEFI hardware. It says because most 64-bit computers are backwards compatible to 32-bit programs and apps as well. In terms of the BIOS, which is a legacy program, it's on the ROM chip. Excuse me, I'm going to read it the way it says. The BIOS is a legacy program stored in a read-only memory or ROM, and this chip that works with the CPU automatically loads and executes when it receives power. Important things to know: the BIOS controls the startup process and loads the operating system into memory. Same thing the UEFI does, because they're basically same chip, UEFI, more modern. The BIOS's firmware says you should frequently check for BIOS updates, because when you have a BIOS update, that gives you additional functionality to your motherboard chip. Same with your cell phone. If you get an update on that chip, then you have to ensure that you update your phone, because it's going to have new virus signatures, new operating system features, new motherboard features, new abilities to support different apps and things of that nature. Okay. Your BIOS chips vary from 265 kilobytes to 1 megabyte in size. So as you can see, very small storage capacity. These chips are referred to as EEPROM. electronically erasable programmable memory. Programmable memory or read-only memory. So this chip has to be shocked, and then the new information is deleted. I mean, the old information is deleted, and then the new information is installed or updated on that chip. Okay. EEPROM replaced EEPROM, which was, before that, built in 1994. Right. CMOS, we talked about the CMOS as well. It's a battery that controls the clock and the calendar. Okay. If your clock and your calendar go bad, you replace the CMOS battery. If you install a BIOS password and don't remember your BIOS password, you take the CMOS battery out, and then it'll reset your password. Okay. Also, remember that your CMOS used to have the same functions as the BIOS. The chip that the battery sits in used to have the same function as the BIOS, but now all it does is keep the time and the calendar, and helps to save information when your computer is turned off. Okay. It says common reasons for editing the CMOS settings are as follows. So let me just start here. During the computer startup procedure, you can press one or more keys to open the CMOS editor to change the data stored in the CMOS memory. The CMOS setup program is part of the BIOS program. The key or keys you press to open the CMOS editor depend on the BIOS manufacturer. The easiest way to find out which key is pressed is to read the screen as it boots or to consult the motherboard documentation. Remember, I told you that some of the answers to some questions may be that you're going to consult the motherboard documentation or you're going to go to the manufacturer's website. Okay. Here are the most common keys to access the BIOS: delete, insert, F1, and F2. Reasons for editing a CMOS are to change the boot device order, because if you have multiple hard drives, there's an order that that your disk must boot. And one of the reasons is because your operating system sits on the primary or the active partition. Okay. So you can enable or disable motherboard devices, and you can add a password to set up certain programs, okay, or prevent unauthorized access. And this is one of the great features that's associated with the BIOS UEFI. It says if you set a BIOS UEFI password and then forget, you will be unable to edit CMOS settings. So it says to do this, you just want to remove the battery. Okay. I'm going to leave the rest of this for you to read, and make sure you read through the rest of this because it has the actual process, the booting process from when you first hit the power button to when the operating system loads on the RAM chips. Okay. So let's kind of move on. I'm going to show this system information. This is just going to be
Before you move on,
uh-huh.
question.
Go right
The
ahead.
CMOS, and I'm sorry, I don't want to sound like I'm asking a crazy question,
No,
but
no
that's only
question. No question.
for a regular CPU, right? You
Say
can't
it
do
again.
the same thing with, is that only with the regular size CPU, the smaller peripherals? Can you do the same thing?
Can you restate your question again?
I was saying the smaller peripherals like iPads and things like that, they do not have the same kind of battery that you can use to reset, right?
Well, it's not the battery per se, but let's see. Can you? I'm pretty sure you can. Can you access the BIOS for UEFI on a tablet? How to get into the BIOS on a tablet? You have videos to do so. I'm looking for the actual. Why don't Android tablets use UEFI or legacy mobile tech? Now, I will say this: most tablets and cell phones use a different technology called ARM, ARM. Okay, but let's see here how to access a UEFI BIOS on a Windows tablet. It says access UEF BIOS on a Windows 10 system PC. That's for a PC. I want a laptop. All right, here's the quick way for a Surface tablet. It says 1, make sure the Surface tablet is powered off. Let me make that larger so we all can see. 2, press then release the power button while pressing and holding the volume up button on the left. As you can see, power, volume up button. 3 says release the volume up button when the Surface logo is displayed. Then UEFI BIOS setup should display. And I think that was it. It says when you successfully access the UEFI BIOS in a Windows 10 or Windows 11, depending upon the device, you can make some changes to your PC laptop. Let's see if we can do it for a cell phone. You said cell phones used to use access code 72786 to access BIOS on devices. Yep, a long time ago. Can you access your on a cell phone? Yes, BIOS is there in smartphones, but unlike a PC, you don't have access to the BIOS, and thus you won't be able to change the operating system of the smartphone. But in PCs, you can by using a bootable pen drive or a CD or flash. The operating system of a smartphone is stored in a floppy drive, which users cannot access. I don't think they meant to say floppy. All right. It says phones don't have a BIOS though. They have a firmware. So we call it a firmware chip. So that's really, we receive those updates. So those companies send us those updates. Is the UEFI? Oh, that's just saying stuff we already know. I hope that answers your question. All right. So let's take let me see everything we're going to go through today. BIOS UEFI, processors, processor troubleshooting, video expansion cards, audio, cooling, and power supplies. We're going to get through all this tonight. All right. So I'm going to show this quick video because I want you to see what the BIOS settings look like here. Okay. And we did flashing the BIOS yesterday. And then we'll look at a video on how you configure BIOS and UEFI settings. All right. So let's take a look at this video.
In this demonstration, we're going to talk about how to configure BIOS or UEFI configuration settings. You do this by accessing the appropriate firmware configuration utility for your system. The way you access this utility depends on the system that you're working with. Usually, it's a single key that you press as the system boots before the operating system loads. Consult your system's documentation to learn exactly which key it is. On the system we're working with here, note that it already tried to boot.
Can anybody else see the video?
We can hear the sound. No video.
That's crazy. Let's go here once again. I have everything selected. Can you see it now? Where it says no bootable device found?
No.
I can see it on my screen, but nothing really changed.
Boot, but it couldn't find an operating system.
Did you see that? You saw that right there?
Oh, there it is. There it is.
Yeah, that's it. Okay. All right.
In this demonstration, we're going to talk about how to configure BIOS or UEFI configuration settings. You do this by accessing the appropriate firmware configuration utility for your system.
It went back out, Mr.
The way you access this utility depends on the system that you're working with. Usually, it's a single key that you press as a system.
So you don't see the terminology at the top where it says no bootable devices found?
Yeah, I see. Okay. So that's the video.
Yeah, that's the video. Yeah.
Oh, okay. All right,
So,
cool.
yeah. So they're just going through the process. They're going to explain it. Okay.
Okay.
System boots before the operating system loads. Consult your system's documentation to learn exactly which key it is. On the system we're working with here, Note that it already tried to boot, but it couldn't find an operating system. That's because it has nothing but blank hard drives. There's no operating systems installed, so no bootable devices were found. As a result, it displayed several messages that I can use to find the appropriate keystroke to access my firmware configuration utility. Notice that the second option lets me know that I can use the F2 or delete key to enter the firmware setup. I'm going to reboot the system, and during the boot process, I'm going to press the F2 key. Notice that when I do, instead of trying to boot the system, my firmware configuration utility interface is displayed instead. Keep in mind that the interface displayed here may be significantly different from what you see on your system. In this particular user interface, you'll notice that the screen is divided into two areas. We have a settings structure tree on the left that we can use to select a particular setting area. On the right, we have information associated with each section. On the left, Settings, General, System Information is selected by default. On the right, the system hardware information is displayed. This is a very valuable screen. You can learn a lot about the hardware on your computer by reviewing the information here. For example, we can see that it has 4096 megabytes or 4 gigabytes of RAM installed. We can see the speed of the memory modules, and we can see the memory channel mode. Here, the memory is operating in single channel mode. If I wanted to improve system performance, I could enable either dual channel or triple channel mode. If you see single channel listed as the memory channel mode, it means that your memory is running as slow as it possibly can. The memory technology is also displayed. This tells you which memory slots are populated. Notice that we have 4096 megabytes memory module in slot DIMM A size, and the remaining slots are empty. To enable either dual or triple channel mode on this system, I'd populate the appropriate slots with additional modules. Under Processor Information, we can view more information about the processor. It's an Intel Core i7 CPU. That's a pretty fast one. It has 2 cores. It tells you what the clock speed is, and it gives you the size of the processor cache. Further down, we can see the various hard disk drives that have been installed. You see that we currently have 3. The first one is 500 gigabytes, and the other 2 are 250 gigabytes. We can also see the video and audio controllers. This type of hardware information screen is standard on most BIOS and UEFI configuration interfaces. Another thing you can do here is set the date and time. Remember that your motherboard has a little clock and it's powered by a battery. This clock keeps the time while the system is turned off. Understand that the clock isn't perfect. Time will drift. If it drifts too much, you may need to come in here and reset it. Another thing we can do in the firmware configuration interface is enable or disable the various onboard devices. Let's go over here to System Configuration. Notice that under System Configuration, I have options for my integrated NIC, my parallel port, and my serial port. I can configure how my SATA interface on the motherboard is going to operate. I can enable audio. I can configure my USB, and so on. For example, if we come over here to Integrated NIC, you see that it's turned on by default. I can plug a network cable into the built-in port on the motherboard and have it participate on my wired network. In addition, we can come down here and enable the parallel port that's built into the motherboard. By default, it's turned off on this system. If I wanted to turn it on, I could select one of the appropriate modes here. It tells me in the information box what those different modes are. This brings up a very important point, and that's that most good motherboard manufacturers provide a little bit of help within the BIOS or UEFI configuration interface. Where that help is located depends on the system. On this system, it's beneath the settings. On older systems, you'll see it displayed on the right. If you don't know what a particular setting does, just consult the built-in help. It'll save you a lot of time. In this case, if I wanted my parallel port to be enabled, and I wanted it to run in ECP mode, I'd select the ECP option and click Apply. We can do the same thing with our serial port. Currently, the serial port on the back of the motherboard is disabled. If I wanted to turn it on, I'd mark the appropriate option, either COM1, COM2, COM3, or COM4. In the Help section, it tells me the I/O port and the IRQ that the port will use as a result of the selection I made. Another cool thing is Smart Reporting. SMART stands for Self-Monitoring Analysis and Reporting Technology. It's used to monitor the overall.
I'm going to play that again because you have to know that for the exam. Okay, that's associated with hard drives. So if there's issues with your hard drive, then smart technology will start working and it'll display contents on the screen like you should change your hard drive soon. It's going bad.
Cool thing is smart reporting. SMART stands for Self-Monitoring Analysis and Reporting Technology. It's used to monitor the overall health of your storage devices because hard disk drives and mechanical devices wear out over time. SMART keeps track of the areas that have worn out and reserves others. When you run out of reserve areas, you'll start getting SMART errors, but you must have SMART reporting enabled for that to happen. Receiving these warnings gives you the opportunity to get your data moved over to a new hard disk drive before it fails completely. Let's come down to USB configuration. Here we can decide how we want the USB ports on the back of the motherboard to operate. For example, we may want that USB port to operate in USB 3.0 mode, so we can get the best speed possible. In this case, we want to make sure that we select Enable USB 3.0 controller. If you want to be able to boot the system from a USB port, which is great from a hardware technician standpoint, we'd select Enable Boot Support. From a security standpoint, though, this isn't that great of an option. It potentially allows an attacker or malicious insider to insert a USB drive with an operating system on it and boot the system from that drive. The attacker could potentially access the data on the system hard disk drive, going around the various authentication and security mechanisms you've implemented.
Now let me say this. Now, know that a lot of financial institutions, you cannot install or you cannot plug a flash drive or external hard drives into the computer. It's just something they haven't detected that the IT team will be alerted when you put something into their computers because they don't want you to steal financial information. You know, you have your laws that are in place that protects the integrity of that information. And that's a policy that most financial institutions have. So booting your computer by a flash drive, that'll be disabled. Please make note that when I stop you and I highlight something, you may see questions related to that on the exam.
For security reasons, you probably want to turn this off. In fact, a lot of system administrators who are really security conscious turn the USB port off completely by deselecting Enable External USB port. You can also turn your soundboard on. This motherboard has a built-in sound interface. If you want to use it, you click Audio under Settings, and then select Enable Audio. If you want to use a different audio interface, maybe you have a really nice audio card and expansion slot, I'd suggest deselecting the Enable Audio option. That way, the system will use the audio interface on the expansion board instead of the built-in one. Let's go to Secure Boot next. Secure Boot is a very important feature of newer systems that uses the UEFI firmware instead of the older BIOS firmware. Secure Boot prevents the firmware from loading an operating system off the hard disk drive unless it has the appropriate security certificate for that operating system. Secure Boot is designed to prevent malicious attacks. It prevents attacks done with rootkits or with the attacker booting the system off an optical or USB drive. We talked about the second type of attacker earlier. It's where an attacker boots your system using a different operating system to bypass your security mechanism. By default, this option is usually turned on, which is good if you're running Windows. But if you want to install some other operating system, this can cause problems. For example, some Linux distributions aren't UEFI compliant. If you try to install one of those distributions, your UEFI firmware won't have a security certificate for the operating system, so the system won't boot. In that situation, you need to turn Secure Boot off. Technically, turning it off does make the system less secure, but it is necessary for some things. Let's go to Performance next. Under Performance, there are several different processor-specific performance options we can configure. Again, the performance options you'll see will vary depending on manufacturer and model. As we saw earlier, this system has a Core i7 processor installed with 2 cores. If we go to multi-core support, you see that we can turn multi-core support on or off. Right now it's running with multi-core support turned on, and both cores in the CPU are being used. Most likely that's what you want. If you wanted your processor to be slower for some reason, you could turn this option off, I guess. In that case, only one core within the CPU would be used. I can't think of a good reason to do that, but you could if you wanted to. We can also configure hyperthread control. Hyperthreading allows each core within the CPU to run 2 processes concurrently instead of just one. By default, it's turned on. So even though we have only 2 cores in this CPU, by having hyperthreading turned on, we can run 4 processes concurrently at the same time. Again, if for some reason you wanted to, you could turn it off. Next, let's go to post behavior. Under Post Behavior, we can configure how the system behaves when it boots up. One of the features that you may want to look at is Extend BIOS Post Time. By default, it's set to 0 seconds. That means that there's no delay as the system boots. No delay really doesn't give you time to press the keystroke to access the configuration interface that we're in right now. For most users, that may be a good thing. You don't want that message displayed for very long. But there may be situations when you need that message displayed for a longer period of time so that you have time to press the appropriate key. In that case, you could change it from 0 to 5 seconds or even 10. If you do, be aware that it does slow down the boot process because the system's going to sit there for 5 or 10 seconds before it finishes booting up. The last thing we want to look at is virtualization support. Virtualization support enables you to run virtual machines. This can be useful if you're developing apps, developing training, and so on. It allows you to run multiple instances of different operating systems all at the same time, all on the same CPU. For this work, you have to turn virtualization on in here. Some CPUs will have it turned on by default and others won't. This one didn't have it turned on. If I want to turn it on, I select Enable Intel Virtualization Technology and click Apply. We've made a few changes as we've gone through the configuration interface, so for these to be applied, we have to do two things. First, we need to save the changes, and then we need to reboot the system. Once again, the way you save the changes will vary depending on the make and model of your system. With some firmware configuration interfaces, you need to press a particular keystroke, like F10. On this system, all I need to do is click Exit and the changes are saved. That's it for this demonstration. In this demo, we talked about accessing our BIOS or UEFI configuration utility and changing some of the settings found there.
Hey, y'all should have let me know I had the mic off. Y'all heard me rustling the bag and all kinds of stuff, right? What I want to do now is kind of, I don't know why the mic kept cutting off. Anyway, so let's go to some other content. Finding BIOS UEFI settings, understanding UEFI security. We kind of looked at that a little bit, but let's look over the security facts first, and then we'll move into the next section. Give me a second. Okay. So we talked about passwords and the ability to set an administrative password. It's sometimes called a supervisor or setup password. Like if you're at work and you're trying to access certain things, and then the information will come up where you can't do certain things, and it'll ask you for an administrative password. You can set that up in the BIOS. Okay. So that's one of the things that you can think about. Here it says the user password, sometimes called a system or the power on password, requires the user to authenticate to boot the operating system. Usually you can use the administrator password to start the system. BIOS and UEFI passwords offer only a limited degree of protection. There's also something that's called drive locking. It's setting a password on the system hard disk drive. Some motherboards allow this and some don't. When you set the password, it must be given at system startup and the disk cannot be used, okay? Remember we said to fix these, you take out the CMOS battery, okay? And then that'll reset the password and it'll go back to its state it was before, then no password will be in the system, okay? Sometimes there's chassis intrusion. So at some organizations, if you try to open up the computer, then an alarm will be set off and IT will know that someone's trying to open a computer. Okay. So that's called chassis intrusion detection. We talked about trusted platform module. We brought it up. But the thing to know about this, that TPM generates and stores cryptographic keys. You can't use BitLocker without TPM enabled, and you can't set up LoJack or anything like that, because these are encryption keys. Please hold on to that term, encryption keys. It'll make more sense when we talk about security later on in like the 1102 section of this course. So just to give you a little more information, TPM can generate what is called a cryptographic key or a hash. A hash is a one-way algorithm. I explained that before. So every time you enter your username and password, your computer evaluates the hash that was created from you entering your username and password. Just to give you some information right here, there are two types of hashes. Two types of hashes. So I will be asking questions in regard to this, and not corned beef hash either. I know it's old. Security. Let me type wrong. My cup was in the way. Two types of hash. Let me say security. All right. So these are the two types. Just this term, SHA, and then you also have one that's called MD5. So SHA and MD5 are the two types of hashing algorithms. Okay, here, click here. It says, what are the two types of hashing algorithms? And right now, you have SHA 0, 1, 2, and 256 or 512. But if you read this one right here, it says SHA 1 is a 160-bit hash function which resembles the earlier MD5 algorithm. Okay, so what we need to do now is kind of explain what is a hash. Okay, hashing in a data security technique is used to convert data values into alternate unique identifiers called hashes for quick and secure access. Let's look at it like this. You want to gain access into your, let's say, security locker. But in order to gain access, you have a lock and you have to twist and turn in different ways. Even though it's electronic, you have to twist and turn to get the right code. Once you get the right code, pop, the lock opens. Same thing with your username and password. When you enter the correct username and password, the computer has already stored a hash value. Data security technique used to convert data values into alternate, unique identifiers called hashes for quick and secure access. Hashes can be used for data security because the one-way process prevents access to or tampering with the source, okay, or source data. So in cybersecurity, you use hashes in cyber forensics. Someone commits a crime, there's a computer, you're embezzling money. They will take the computer before they leave. They will put a flash drive in that computer, and that computer, the flash drive will make a copy of the hard drive and all apps that are running and all of those things. They'll pull the computer off the system, okay, off the network. Then they'll transport that computer to either lockup or to a lab. Once that computer gets to a lab, they're going to log back into that computer, grab another flash with the same software on it, create another hash. Then they'll take the data from both drives, they'll look at the hashes, and they'll compare them because they want to see if the device has been tampered with. That's why they tell, like, if police officers are handling evidence, they'll say, don't stop off to get nothing to drink. Don't stop to use the bathroom. Don't do anything, because if that computer comes to the lab and the hashes are not the same, that officer's in trouble. And that evidence cannot be used in court because it's inadmissible. It doesn't work. Okay. And that's what I teach when I teach cyber forensics. All right. Okay. Let's move back to this. Any questions? Please stop me. If something's confusing, like Mr. Helton, don't make sense. Stop me. Okay. So remember, TPM must be enabled on your motherboard. Okay. Once TPM is enabled, testing 1, 2. Why does it seem like my microphone is not? Are y'all getting sound? Hello?
I can
Yeah, we
hear you
can hear you.
fine.
Okay, because I didn't see I didn't see it jumping. Okay. All right. So those are the things that you really want to, and remember, I said this process is understanding terminology. So you have to set that terminology before you every day. These are the terms we went over in class. These are the terms I'm going to review. And I'm just going to study these terms. And when I study these terms, it should make sense after time. Okay. Especially when we start doing more of the labs and really applying some of the concepts, and quizzes, because I'll be quizzing you a lot to try to prepare you for the exam. So then there's the concept called secure boot. Secure boot prevents the booting of unauthorized operating systems. It does the following: prevents the system from booting an operating system installed on a removable USB drive that could access data on the system hard drive. Because cryptographic keys or security keys are being created, there's a code that's being created. And when you try to install from that hard drive, excuse me, or the USB drive, it's not going to have the same code on it. And the firmware, as well as the TPM and the cryptographic keys, is going to prevent you to be able to make changes to that motherboard. Okay. All right. Now, remember, it's a lot of information I'm giving you, but at the same time, what I want you to do is I want you to draw connections. Your first connection when we're talking about BIOS and UEFI is what they have in common. And what they have in common is they have the POST, P-O-S-T, power on self-test, and then they go to find the operating system. Okay? They are both shocked, and when they're shocked, the current firmware instructions are deleted, and then the new firmware instructions are installed. Just like your cell phone with your firmware update. Same thing happens. That's why they always tell you that your phone has to be powered up to about 50%. Or you have your power cable must be plugged in. And then typically those updates happen at night when no one should be bothering their phone. Just depends on, what type of person you are. Or if you're a night owl. Okay. So remember the concepts, relate this stuff to your everyday life. When you relate it to the everyday things that you do, you'll see how embedded in technology you actually are. No one can escape it. Now we want to talk about CPUs, the processor, the CPU, central processing unit, or the processor, okay? The processor is so important because it is the brain of this whole system, okay? You have different processors for servers, different processors for personal computers, for laptops, for cell phones, and there's different technology for each of these different systems. There are two main processor manufacturers. One is Intel and the other is AMD. But in the past 3 to 4 years, we've had Apple come along and say, no, we're going to build our own silicon chip. As most people say silicon, but silicon chip. We're going to build our own processor. So now we have the M1, the M2, and the M3 processor, okay? And I'll guarantee you it's amazing. I think it's the best. I think Apple has something here. But the two main processor manufacturing companies are Intel and AMD. So we're going to get into those, and we're going to learn some more facts about those. So before we get into it, let's talk about a concept called cache, okay? Cache memory used to sit on the motherboard. There was a chip that was really to help in productivity. So that the CPU didn't have to go all the way back to RAM or all the way back to the hard drive. Some of your most common searches, the common things you would do, was stored on the cache chip. Developers took this chip off the motherboard and placed it inside of the CPU. Let me give you an image that can help you to understand this. CPU cache. All right, so we're going to look at images, but let's go over this definition first. A CPU cache is a hardware cache used by the central processing unit of a computer to reduce the average cost time or energy to access data from the main memory. A cache is a smaller faster memory located closer to the processor core, which stores copies of data for frequently used main memory locations. So if you use Word and you've just done a Word document and you use it a lot, it's going to save some of that stuff in the cache. If you use Excel, whatever apps and applications you like to use, that'll be saved in cache. Your internet searches are saved in cache. I'll give you a quick example and then we'll get into the lesson. So I was teaching Linux at CCBC, Community College of Baltimore County, and I had a student who was going to the Rolling Loud concert festival. And he said, I'm going there. He said, I'm a videographer. I will be recording a lot of the things that are taking place there. I'll be recording the artist and interviewing the artist. I said, yeah, sure, go ahead. This was around finals time. So I created the final. We're getting ready to take the final. He calls me while I'm in class. He said, I'm trying to access the final. I cannot get the final on my computer. So this is where experimentation really helps. So I sat there and I said, why can't he get, he said, I've been trying and trying and trying, but I can't access the exam. And then all of a sudden it dawned on me, it hit me and said, boom, this happened to me. I said, you got to clear your cache. I said, your CPU cache is full. When your CPU cache is full, you can't access websites. You can't do certain things. Okay. It's kind of like your memory. If someone keeps asking you questions and asking you questions, at some point, you're going to be like, okay, I'm done. I'm ready to go to bed. Or I'm ready to take a rest or a break. So these are some of the things that I want you to conceptually see. Okay. Now, altogether, you can have 4 instances of cache. We call them levels. So you have level 1, level 2, level 3, and level 4. The level 1 is closest to the CPU. Let me get you an image. Let's do, I normally do this one, but that has L3. I'm looking for something with L4. L4 cache. Let me do this. Level 4. Or level 1. L1 to L4. CPU cache. All right, just okay. Here's the image that I typically get, even though that's L3. I don't see one with L4 because I just want to show you so you can visually see what I'm talking about. Well, I'll just use this image right here because I don't see an L4. All right, now click here. When you clear the cache, you lose your you lose your most common searches. Okay, so if you clear your cache, you're gonna lose your some of your browser. You may lose your browser information. It just depends. When I go into settings or more tools, I go into settings and I typically type cache. And when you go on cache, you click clear browsing data. So sometimes I don't delete my browsing history and I don't delete my download history because I sometimes store stuff there. Now, for a performance measure, you should never keep temporary files or files in the download history. You should take those files and move them somewhere else because it increases the performance of your computer. Remember that. I recently just pulled stuff out of my downloads folder. And as you can see, I'm starting to load it back up again. So I had like almost 32 gigabytes of information in the downloads folder. That's a lot. So I removed a good majority of that because that frees up your computer when you're going to do certain things or if you're downloading certain things. So every website you go to, just to give you a little background, every website you go to, those images are cached, okay? Even if you come here and I was to type A, then it's going to memorize my browse history searches. If I type B, this is the cache working, okay? C gives you a list of the websites and things that you go to. V, okay? It just shows you things that you do. This is the cache at work. if I was to right click here and go to File Explorer, and you have, typically they'll have like this is your quick list right here. All this quick list information is your cache at work. So I go to my downloads folder a lot, my desktop, my documents folder, my pictures, I go there a lot. Splice, these are the things that I do the most. So my cache is at work here so that I don't have to do so much in searching for things. Okay, let me get back to this image. So here's the image that I'm referring to, and this is a CPU with cores, or what we call, it's a multi-core. What is this here? Customize set up cookies, necessary cookies only. So here's your processor, and it says processor graphics, but this is a quad core processor. So you have 4 cores. So what can happen here is that you can run multiple programs, and the programs could be working in different cores, meaning that you basically have 4 different CPUs or processors. You can stream something or download something, and your programs get threaded into a core, sometimes multiple cores if it's trying to do multi-processing. Okay, so that's what cores are for, so that you can process many apps, background things. This is like 4 different brains. Yes, like 4 different brains. You're absolutely correct. So you have cache here. So you have L1, which is going to sit closer to the processor. You have L2, which is going to be a little larger than L1, but not as big as L3. So it's going to be like certain searches. And if it can't find certain things, and you have a level 4 cache, and it's not sitting in the level 3 cache, which is larger, then it'll go to the level 4 cache, which will be a little, it'll be a little more space, so that they can search that information. So one thing about this mock-up of this processor, you saw are all the cores sharing the same cache? Yes, they will be sharing the same cache, but it may be information from one core on L3 or L4. It just depends when the processor goes to search, where is it going to find it, or where is it stored. So remember, we were talking, someone brought up the front side bus, which I thought was cool that someone knew that there's a front side bus, but that's associated with legacy systems. They've moved so many things inside the processor, such as the memory controller and certain things, that you don't need a front side bus anymore. Processors do so much now. So you used to have these big pathways of wires that lead up to the CPU. You don't need that anymore. But there are still buses or large, excuse me, large pathways of wires that lead to the processor. All right. Let's go here. And I know I'm moving a little fast. Just, we're going to 8 and it's now 7:19. So I was trying to cover a lot. So with the processors, give me 1 second. Yes. Most of your processors are proprietary. Yeah. They won't let you. Now, operating systems are a little different. So Windows is proprietary, Mac is proprietary, Linux is not proprietary, depending on the distribution of Linux. You can actually purchase the source code for Linux or the kernel and build your own Linux. And if you build your own Linux system and it gets accepted, what will happen is they'll probably write your name into the code. So this will, that's the beauty of Linux. You can take Linux and build your own Linux operating system off of it as well. Okay, so let's go over these things that we're going to learn about here. We're going to learn about the limitations of a 32-bit processor. Remember, a 32-bit processor will only allow you to use 4 gigabytes of RAM and a smaller size hard drive. typically about 4 gigabytes. Okay. We're going to learn about the benefits of using smaller processor sizes during CPU processing unit manufacturing. It says, what is the difference between hyper-threading and multi-threading? So we're going to learn what threading is, what's hyper-threading, and multi-threading. Okay. Basically, multi-threading is running multiple threads of a program into a core. So when we say threading, it's kind of like downloading a movie. You don't get the whole movie immediately. You download the movie and the movie gets streamed to you. Okay. So in the CPU, once you ask a program to run, the full program may not run in that core. Or you may have it where you have multiple instances of that program running in a particular core. I'll show a video and it'll try to draw it home and make more sense. We're going to understand the CPU as it relates to virtualization. And we're going to go over these terms. Multi-core, processor that has multiple processors within a single processor package, or what we call a die, DYE. Throttling. Throttling is when you slow down the capabilities of that processor, okay? Since the process of modifying the operation characteristics of a processor based on current conditions. Less voltages of electricity will take place, meaning the processor won't think as fast as it normally would do or make calculations. Overclocking is when you speed up the calculations. You're going to apply more electricity. Your RAM has to run faster. That's why I say your RAM, if your CPU has a certain amount of megahertz, which is going to be your frequency, your RAM has to have an equivalent frequency or a higher frequency. So if you have a 2.8 gigahertz or 2.8 megahertz, your processor has to be equal to it or higher if you're going to overclock. Just the concept of if you want to run things in your home, you're going to have more power come into your home. That's what we're referring to. Because your CPU, your RAM has to process faster or refresh faster. Virtualization, the ability to install and run multiple operating systems simultaneously on a single physical machine. And we have talked about that. So this objective is going to be still in a hardware domain, but given a scenario, install and configure motherboards, central processing units, and add-on cards. So we're going to talk about CPU architecture, what's an x64 and x86. So this is 64-bit, 32-bit. If you were to look at your files, let's go to File Explorer real quick and click on this PC and then go into the C drive. You will typically see these two files here. These are 64-bit programs and these are 32-bit programs. So I'm running a 64-bit operating system. My motherboard handles 64-bit functions. My processor handles 64-bit functions and apps and applications and processes, but we can also use 32-bit. So that's what x86 represents. Really, both of these are x86. It's x86 64, x86 32 for 32-bit programs. Please hold on to that. 64-bit, 32-bit, okay? If I was to click in here, here are all my 32-bit programs. If I click in here, here are all my 64-bit programs, okay? Or the file folders that are associated with those particular programs. So we'll talk about multi-core, virtualization support, multi-threading, and we've already talked about cooling fans, heat sinks, the thermal paste, and liquid cooling as well. So let's get into it. Let's look at the first video, processor concepts.
In this lesson, we're going to spend some time discussing the brains of any computer system, and that's the central processing unit, which we call the CPU or processor. Let's begin this lesson by discussing the role and function of the CPU. The CPU is an integrated circuit and contains millions of microscopic circuits called logic gates. They're all connected by hairline strands of aluminum that work together to store and manipulate data. A CPU can accept instructions or programs and execute those instructions to perform both arithmetic and logical operations. These instructions may tell the CPU to perform tasks. It could prompt the user to enter a series of numbers, read the input from the system keyboard as the user types them, store those numbers in specific memory locations in the system RAM, use arithmetic functions to add all of those numbers together, and then write the result to a new location in the system RAM. Write a message on the screen explaining the result, and then open a file on the hard drive and write the result to that file, or to save the file and then close it. So, when we say the CPU is the brains of the computer, we really aren't kidding. Without a CPU, none of the other components in the system would be able to do anything. The CPU connects to the rest of the system using a special socket on the motherboard. This socket contains a series of many small connectors into which you plug the CPU. And by doing this, electric connections are established with the motherboard bus, which, in turn, connects the CPU to other components in your system, like the system RAM, your storage devices, your video interface, and other expansion cards that are installed in the expansion slots. You also need to be familiar with the CPU's clock speed. The clock speed identifies the rate at which the CPU can execute instructions. The clock speed is measured in gigahertz. The CPU requires a fixed number of clock ticks to execute each instruction. Generally speaking, the faster the CPU's clock speed, the more instructions it can execute per second. The clock speed is very important. Understand that for all components connected to the motherboard to communicate with each other, such as the RAM, the CPU, and the expansion cards, the components must be synchronized to the same clock. Therefore, your CPU's clock speed must be supported by the motherboard, and vice versa. With that in mind, we need to talk about overclocking. Beware that, with most systems, the CPU, the RAM, and the motherboard can be overclocked to a degree. Overclocking is pushing a CPU beyond its design specifications. You can gain a marginal increase in performance by doing this. Intel's Turbo Boost technology allows the processor to dynamically run above its rate speed. It also allows the CPU to overclock as needed. Overclocking basically increases the speed that the clock runs. Because the clock runs faster, the CPU, the memory, and the motherboard all run faster too. In theory, this provides better performance. However, beware that the improved performance comes at a price. Overclocked systems tend to run much hotter and consume more electricity, and the increased temperature can significantly reduce the lifespan of the CPU, as well as the other components in the system. In addition, if you push the CPU too fast, you'll probably experience system instability. So you must decide whether the increased performance is worth the shortened lifespan of the device, as well as the potential instability of the system overall. With that in mind, let's shift gears and talk about CPU cache memory. The important thing to understand here is that the CPU has its own built-in memory. We call it the CPU cache. CPU cache is different from system RAM. The CPU cache is made up of static random access memory chips, or SRAM, which are very fast. In fact, they're much faster than the DRAM chips that system RAM chips are made from. The CPU cache is used to store a copy of frequently accessed information from the system RAM. This can significantly increase performance. With this in mind, let's talk about the concept of a core. In early CPUs, there was one processor within each CPU package. In other words, it only had a single core. If you wanted really great performance from a computer system, you could purchase a special motherboard that had 2 or more CPU sockets, allowing you to implement multiple CPUs at the same time. Today, however, most CPUs have multiple processors or cores within the same CPU package. Implementing multiple cores dramatically improves the system performance. The key thing to remember is that a multi-core CPU can execute more than one instruction at a time. For example, if you have 4 cores within your CPU, each core can execute an instruction concurrently. So, instead of processing just one single instruction, the CPU can execute 4 instructions at the same time. In addition to multiple cores, some CPUs also support multi-threading. Multi-threading allows a single core within a CPU to execute 2 instructions at the same time. Multi-threading can also increase system performance, especially if it's implemented within a multi-core CPU. For example, if you have a CPU that has 4 cores and each one of those cores is a multi-threading core, that CPU can run 8 instructions concurrently. Some CPUs also support hyperthreading. In 2002, Intel introduced the hyperthreading technology. This technology is owned by Intel. Hyperthreading is a form of simultaneous multi-threading technology. With hyperthreading, one physical core appears to the operating system as 2 processors. This allows one core to process two instructions at the same time. The two processes can also use the same resources. So if resources for one process aren't available, then another process can continue if its resources are available. Hyperthreading gives you about a 20% increase in performance. Hyperthreading is not to be confused with multi-core or multi-threading technology. There's always a wide variety of CPUs available to you, and some are better for creating graphics, crunching numbers, playing games, and so on. A GPU, or graphics processing unit, is a programmable logic processor specialized for display functions. The GPU renders images, animations, and video for the computer's screen. GPUs are located on plug-in cards, in a chipset on the motherboard, or in the same chip as the CPU. If it's on the same chip as the CPU, it's called an integrated GPU. Let's discuss virtualization technology. Virtualization is the ability to install and run multiple operating systems simultaneously on a single physical machine. Let's say we have a data center with 4 servers and 4 physical platforms, each running an application. There's a database server, an application server, an email server, and a file server. Now, suppose we combine these services virtually onto one server platform. These servers still exist, but they exist as virtual machines running under a single host OS on a single hardware platform. That's the concept of virtualization. The virtual machines appear as self-contained and separate physical systems. Each virtual machine looks and acts like a traditional computer system. If your computer will be used as a virtualization system, then you need to make sure that the CPU you want to implement supports virtualization. Now, let's discuss cooling. When you work with modern CPUs, you have to keep cooling foremost in your mind. Sometimes people turn their systems on for testing purposes without the CPU cooler installed. This is a bad idea because modern CPUs generate a lot of heat. Heat is bad for your computer systems. An uncooled CPU will burn up in less than a minute. CPUs use a heatsink, fan, thermal paste, liquid, or fanless cooling systems to transfer heat from the CPU to the cooling unit. Install a heatsink and fan before you ever turn the system on. There are several different CPU cooling options available. The first one is to use a heatsink. This can be a more passive form of CPU cooling. The heatsink makes physical contact with the CPU, which essentially increases the CPU's surface area, allowing more heat to be dissipated. A heatsink alone can't adequately cool a CPU. If you're going to use a heatsink, then you should always use it in conjunction with a fan. The fan blows air over the heatsink to increase the airflow. By doing this, we remove more heat from the heatsink more quickly. This is an example of active cooling. Another option available to you is to use heat pipes. Heat pipes are usually implemented in conjunction with a heatsink. The heat pipes are filled with a liquid that absorbs heat from the CPU. As they do, liquids within the pipe evaporate. Because that vapor is less dense than the liquid around it, it rises towards the heatsink on the other end of the heat pipe. Then the heatsink and a fan cool the vapor, causing it to condense back into a liquid. When it does, it drops back down to the CPU on the other end of the heat pipe. The system keeps cycling that way to remove heat from the CPU. This system is usually much more efficient at cooling the CPU than the traditional heatsink and fan, and it's a good example of active cooling. There's a fourth option available that's more expensive and not as widely implemented, the radiator. This option uses a coolant, a fan, a pump, and a radiator, much like your car's cooling system. The coolant cycles through the system, exchanging heat from the CPU to the radiator, where it's dissipated by the fan. No matter which cooling option you use, you need to make sure that you use thermal paste. Thermal paste is critical because it facilitates heat transfer from the CPU to the CPU cooler. With all of this information in mind, let's end this lesson by discussing several key criteria to remember when you're selecting an appropriate CPU in a new implementation. First, you need to identify the purpose of the system. You need to be sure that the CPU you select can perform the task that you want the system to perform. Also, you need to make sure that the CPU is supported by the motherboard. Two considerations need to be taken into account. First of all, is the CPU compatible with a socket on the motherboard? And second, will the motherboard's BIOS or UEFI firmware support that CPU? A CPU may fit into a socket, but that doesn't mean the motherboard itself will support it. You also need to identify the appropriate CPU speed. However, don't rely solely on the CPU's clock speeds when you're making comparisons between processors. There are many other factors that need to be taken into account, such as the CPU architecture, the number of cores,
All right, so let's recap these facts. Okay, we're going to recap the information. CPU, two manufacturers, Intel, AMD. They both work in PC systems and support Windows software, such as servers and things of that nature. They say Intel has a larger market share, just depends on what industry you're in. AMD processors generally cost less, still expensive. Okay. You have 32-bit and 64-bit operating systems and processor architecture. Okay. So if you have a 64-bit operating system, your motherboard and your processor have to also support that as well. So a 32-bit processor can process 32 bits of information at a time. This is why we call it a 32-bit processor. 64-bit processor can process 64 bits of information at a time. So with 32-bit processors, there's a limit of 4 gigabytes. With 64-bit processors, there's a limit, it can go higher, of 16 exabytes, okay, EB, exabytes. The operating systems and applications written for 64-bit programs, but they can be backwards compatible to run on 30, that they will run and accept 32-bit programs, okay? Now, when you see AMD processors and they're labeled, you will typically see AMD, like AMD 64. Intel processors will look a little different, okay? And we'll go into those. You said, what is 1 exabyte? Let's see, 1 exabyte. How big is 1 exabyte? You go right here. 1 petabyte. What's 1 petabyte? It's 1 quintillion. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 zeros behind the 1. Okay. Or 1,000 petabytes or 1 million terabytes. You said, never mind. I hear you. I hear you. All right, let's go back into it. We talked about multi-core, having more than 1 core in a processor. More than 1 core can allow you to run multiple applications simultaneously. Okay. Some applications can be written to execute on multiple processors at the same time. Remember, I said it could be in cores 1 and 2. You could have a program running in core 1 and core 2, or core 3 or 4 if you have a quad core processor. Some motherboards use 2 or more processor sockets to provide a multiple processor solution. The speed of your processor is in megahertz. So remember, your RAM will be in megahertz, your processor will be in megahertz, and this refers to the frequency. The frequency. I'm trying to get these terms in your head. Bandwidth, frequency, speed, megahertz. Go ahead.
Because I know you were saying that they're partition. So are they in partitions, having them like that?
What do
Because
you
I got
mean?
kind of a little bit confused with the, I guess you can do, what was it, the 64 megabytes, and you could break it down into sections, but they're not necessarily partitions, right?
No. That's your cores. Okay. If you buy a 64-bit processor, you can run 64-bit programs. So let me go back and explain there's certain characteristics that are associated with a processor. Okay. You can have multi-core,
Mhm.
multi-threading,
Okay.
multi-processing. Okay. So if you have multiple cores, you have multi-cores, which can allow for multiple programs to be ran in each core. You can have multi-threading, which means you can thread one program. You have multiple threads of a program in one core or running in multiple cores. Multi-processing, because you can have multiple different programs and processes, background processes taking place in different cores. Okay. So remember those things: multi-core, multi-threading, multi-processing. Okay. And remember, when we talk about megahertz of the CPU, the speed or the frequency of the CPU, your RAM and your motherboard have to be compatible. Okay. Here it says you can purchase processors of the same type, but with different speed ratings. When selecting a processor, make sure the motherboard supports the processor speed by reading the motherboard documentation first. That's why I say your motherboard, your CPU, and processor have to have the same frequency. It's like if they try to put a monkey's heart into a page, which they have done. I don't know how long the person lived. I don't think they're here anymore. So you can try to do that, but it may not work as fast, especially if it's not compatible. Most motherboards automatically detect the processor speed. If not, you can use jumpers, or you can edit the CMOS to configure the processor speed. Now, what is a jumper? Okay, jumper. Motherboard jumpers. Motherboard jumpers. Okay, so I want an image. Okay, now see this image right here? This sits on the motherboard. Sometimes when you grab a jumper and you place it on top of this jumper, and you cover the jumper, you can either add functionality or you can actually stop certain functionality or disable certain functionality. So these are what we refer to as jumpers. There are different jumpers all over the motherboard. So you can cover a jumper and delete certain functions, or you can add cables and do different connections to different devices to add additional functionality. So when you install a graphics card, in most cases, you'll have to connect the graphics card to the motherboard. But if you want additional functionality, you might have to use a jumper. So this example right here, I'm gonna go to the actual website, is an example of a jumper. So let's explain. A jumper allows the computer to close an electric circuit, allowing the electricity to flow on a circuit board and perform a function. Jumpers consist of small pins that can be covered with a small plastic box, what is called a jumper block. As shown in the illustration, below the illustration is a picture of what jumpers may look like on your motherboard. All right, and this is the example right here. So you can have a jumper may also be called a jumper shunt or a shunt. Jumpers manually configure computer peripherals such as motherboard, hard drives, modems, sound cards, and you can add additional functionality to the motherboard or a device, or you can stop certain functionality on the motherboard or to a particular device. And that's what a jumper is and how you can use a jumper block to either add or stop certain functionality on the motherboard. We talked about speed, frequency, and we talked about cache. Cache, you have level 1, level 2, level 3, level 4. Cache is inside the processor, level 1. Level 2 is also in the processor. And level 3 is the additional processor. And here it says level 4 cache is shared dynamically between the on-die graphics processor and the CPU. So level 4 will be between the GPU and the CPU. Processor size. Oh, yeah, I want to bring this up as well because you may see questions about this. Understanding what a micron is. Remember when we talked about fiber optic cables, we brought up the term microns. All right, so processor size is expressed in microns. You have to know that term. Your processor size refers to the manufacturing process used to etch transistors on the silicon wafer that will become the CPU. A smaller processor size means smaller transistors, which translates into a smaller CPU die with more transistors and less power consumption. So it may run faster and need less power. All right, so let's take a quick look. Here's Computer Hope. I used to recommend this for my students when I taught high school. Micron. Sorry. And I messed it up. What is a micron? All right. Here's what a micron is. Micron or micrometer is a measurement equal to 1/1,000,000th of a meter. And that's the value. It's 0.000003937 of an inch. Okay. And this is the symbol for a micron. And it says Micron is also a computer memory company. See the Micron company. All right. But that's just a little bit of information about that. Okay. So you can have 0.25 microns or nanometers. So nanometers is the other measurement. So 90 nanometers equals 0.09 microns. Okay. Nanometers, microns. Hyperthreading. Hyperthreading is with Intel processors. It allows a single processor to run threads or instructions in parallel. So when we do hyperthreading, hyperthreading enables a processor to execute 2 threads at the same time. So you can run the same program, you can thread it at the same time. All right. Hyperthreading is not the same as multi-threading. Multi-threading is a feature of an application that allows it to send multiple threads at the same time. Applications are typically written to support multi-threading to take advantage of multiple cores. So you can have more than one thread in more than one core. It says executing threads on 2 or more processors at the same time, or hyperthreading features. Okay. Hyperthreading, running multiple threads in a single processor. Multi-threading is running multiple threads and multiple cores. Throttling, slowing down the characteristics or the speed of the processor. Overclocking, speeding up the specifications of that processor. Intel uses what is called turbo boost. All right. And you have to do this in the motherboard. I mean, in the BIOS. So when you go log into the BIOS, if you want to overclock, you have to set that up there. If you want to throttle, you have to set that up there as well. You have mobile processors. Mobile CPUs are used in mobile computers and cell phones where portability and mobility are a concern. It says special versions of processors are built to minimize power consumption and the amount of heat generated. Because remember, the CPU generates a lot of heat. And we talked about virtualization before. So I'm not going to get too much into it. Just know that it says if you plan to implement a virtual solution, check to see whether hardware support in the CPU is required. Remember, we talked about the term provisioning, okay? Your CPU, your RAM, and your hard drive. So Intel's virtualization technology, if you have an Intel chip, is called Intel VT, okay? Intel's virtualization technology. AMD use AMD-V, okay? You have integrated memory controller, which is on the GPU for faster processing. And then you have cooling, which is your heat sink and fan. All right. It is 750. Let's CPU performance facts. We talked about overclocking. So let's introduce this term real quick. Clock time is the period of the clock that synchronizes the circuits in a processor. So remember we talked about RAM and we talked about synchronous dynamic RAM or SDRAM. So the point of that is to say that your RAM has to have the pulse of the processor and the motherboard. So that's like when you're running, your brain and your heart has to pump blood faster and it has to match what you're trying to do. So your motherboard, which is your body, has to be able to use your memory and your CPU at the same speed, if not higher. Here, it says if two processors are the same type, higher speeds typically means higher performance. With processors of a different type, speeds might not be comparable. So if you buy a RAM that is 2800 and another RAM chip that is 2400, your computer is going to work at 2400. So it won't move faster. Both of the chips will only work at 2400. Okay? So your frequency of your chip has to be the same. Is this making sense? All right, I got a question then. I got to make sure everybody's paying attention. The frequency or the speed of the processor is measured in what? What's the measurement for the processor?
Megahertz.
Ah, that's right, megahertz. Yeah. Okay. If I slow down the processor, that's called what? Say it again. Yeah, absolutely. Good. Oh, y'all paying attention. I love it. Okay. So if I want to run a program in more than one core, that's called what?
Multi-core.
Multi-core and?
Hyper-threading.
Nope, not hyper-threading.
Multi-threading.
Multi-threading. Multi-threading runs programs in more than one core. Hyper-threading runs multiple threads in one core. So if you're running a program, you may have two threads of that program running, because that's what happens. The whole program never goes to the core. It threads the program and runs the
Can you say
program.
that again about the difference between hyper and multi?
Okay. Hyper-threading will run in a single core. So programs, applications will be threaded in a single core, meaning that you can have two threads running at the same time in one single core. It may be a quad core processor, but core one is running two threads of a program to increase performance. That's hyper-threading. Multi-threading. Are you getting ready to say something?
No, I just said, okay, I'm sorry, let me mute.
No, it's fine. Multi-threading is running multiple instances of a program in different cores. So core one may be running the same program, and core four may be running the same program, giving additional performance or a higher level of performance. That's multi-threading, because you're going to be using multiple cores. So remember, the functions of or the characteristics of the CPU is multi-core, multi-threading, multi-processing. All right. Let's see, 754. We kind of, I didn't go over this, but they're like 4 different types of, I still don't know why they teach zero insertion force sockets, but they're different. On the motherboard, there are different types of sockets. You have a land grid array, you have a pin grid array, you have a zero insertion force, and you have a ball grid array. So I'm going to read through them quickly, and then I'll show you images of each one. Land grid array says the LGA. Now remember that, because you're going to see that a lot for Intel. LGA sockets move the connecting pins from the processor to the socket. Okay. So land grid array, the pins are in the motherboard. The pins are not on the processor chip. You'll just flip the chip over and you'll see all these little chips on the bottom of it, or these little connecting parts. So when you sit the processor into the socket and close the processor door or latch, then the pins rise up from the motherboard to touch the processor. As it says here, conducting pins on the bottom of the processor contact the protruding pins from the processor socket. That's LGA, land grid array, meaning the pins are in the motherboard and they're going to rise up to the processor, right? Pin grid array means that the pins are on the processor, which is very bad. Back in the day, you used to destroy your processor. If you bent one pin, the processor was destroyed. So PGA processors have a series of pins in any array on the underside of the processor package. The pins insert into the corresponding receptacles. So if you put that processor in there wrong, you have the ability to damage the processor. There's another socket that's called the zero insertion force. It says the ZIF is an evolution of the PGA, the pin grid array. The pins are carried by the microprocessor and inserted into the socket connectors. A lever acts as a safety device, so no force is exerted when installing or removing the processor. Then you have what is called a ball grid array. You have the BGA is technically not a socket because the microprocessors are permanently mounted in the socket. Since copper balls are soldered directly to the motherboard, it is impossible to upgrade or replace the microprocessor. These are useful in laptops, mobile devices, memory chips, and other electronic boards. So these are how you will read Intel. You're like, I can't remember all this. You're going to see LGA 1156, LGA 1366, okay? LGA 50. And I'll work with you so that it'll start to make more sense. AMD is the easiest because either you're going to get AM or you're going to get FM or FM plus. And then you have the different processor types that are associated with it. And we'll go over that. And we'll touch on that. We'll start touching on that Monday, not Monday, but Wednesday when we see each other. And let me just show you a couple of images of LGA processors. You saw that where it said LGA, the motherboard, because your motherboard socket has to match the processor. But I want you to see the processor. Get that A out of there. I don't want advantages of LGA processor packages. Here we go. Land grid array images. So as you can see, this is a land grid array. You'll just have these connectings on the bottom, the connectors on the bottom. And this is also the instruction set. Okay. The instruction set. So this is land grid array. Okay. That's land grid array. Let's take a look at pin grid array. LGA, PGA. All right. Images. The images. Come on, come on. All right. Here's pin grid array. So as you can see, the pins are actually on the processor. And you'll have to put these pins into the socket like so. And you can damage it if you don't sit it in there the right way. Then you have the ZIF, zero insertion force. So these are ZIF processors. Okay, this is a ZIF socket. Here's a ZIF processor. It still has pins on the bottom, but it's kind of like a combination of both. Okay, and this would be a ZIF socket. And then you have the ball, BAL. Okay, and these are the, here you go, ball grid array processors. Okay, you have the little connectors on the bottom, like so. All right, let's do BGA. All right, ball grid array. There you go. So you see the little copper balls there. That feels weird. Anyway, here's another instance right here, difference between PGA and BGA. All right. Are there any questions?
Should we continue taking the quizzes that you put out there?
Yes, continue taking the quizzes. I'm gonna I didn't get a chance to open them up last night. But I'm gonna try to open them up tonight because it takes a while for me to go through and change the dates. on
Mhm.
each one of the quizzes. But I will do that. Continue to study those, continue to go through those questions, even at the end of every chapter in your book, the CompTIA book. I would use that as a resource as well and go through those chapters, like chapter 1. Let's see, chapter 1 ends on page
It should be a 1, 2,
78.
3. Yeah.
So there are 20
Okay.
questions altogether.
Okay.
So in your book, it goes into things like you're installing a new computer. This is on page 75. And the user wants to use virtualization, which hardware components need to support virtual technology for this to work properly. I'm going to eventually load these questions into the classroom and quiz you on them. Okay. And I'll give you another tip about the book later after I start quizzing you about it.
Okay.
Okay.
I just so you know, I downloaded. I didn't know Audible has the
Okay.
book and a
Okay.
PDF, so it'll read it to you.
Ah, that's good. I didn't
Yeah.
know that.
So yeah, so you can listen to the book as you're doing other stuff.
Okay. That sounds good. That's a good tool.
Mm.
And that's good because I use that as well. Like when I'm preparing for exams, I'll have like the exam content playing in the background while I may be
Okay.
cleaning up, doing something, just so it's subliminally going into my psyche.
Yep.
If there are no further questions, everybody, you have a good night. I will see you on tomorrow. And we'll pick up from here. Everybody else will have to watch the video.
Okay. Thank you.
No
Good
problem.
night.
You have a good night as
Mr.
well.
Helby
Yes.
and everybody.
All right.